Hello everyone, I am Malarvari going to present an overview on artificial intelligent parameter based particle swarm optimization for maximum power point tracking of PV systems under partially shaded conditions. Why the recent research is almost looking on renewable power based generations? Of course, the reason is the source is abundantly available and it is a green source, which means which is not polluting the environment. That's why we are almost going on this optimization of renewable power based generation. Here we are concentrating on solar power based generation. Even the availability of solar energy is high, but it is too difficult to match the availability and the demand. It's too difficult to match these things. For how to optimize this renewable energy performance is the major challenge in the recent research area. That's why we here the objective is to provide optimal renewable energy performance by using fuzzy logic based PSO MPPT algorithm, control algorithm. What is MPPT? MPPT in the sense it is we can extract the maximum available power from the PV panel by operating the duty cycle of the DC to DC converter to the maximum power point. This is actually called as MPPT algorithm. We have enormous MPPT techniques like PNO, hill climbing, and incremental conductance algorithm, many soft computing techniques, and sliding mode control. We have enormous control algorithms, but still this MPPT, the tracking of MPP is gaining its challenges on responding to the input variations of the parameters and steady state oscillations and stability on so on. That's why if the error is too small, we need a highly efficient control algorithm to track the MPP. And that's why still this research is undergoing on this MPPT technique. What is the drawback on those techniques? What can be the drawbacks and why? What can be imposed on proposing a new methodology over MPPT technique? With this conventional techniques like PNO, incremental conductance algorithm, and hill climbing method, the control design is so simple. The control design may be easy to apply, but it can apply only for low cost applications. When we coming for the soft computing technique like fuzzy genetic algorithm and neural based networks, we can track the maximum. It can be very effective in nonlinear problems, but it shows its difficulty in deciding the control structure. It needs some high technical skills to design the control structure. Uh, that's why we are moving to some other things. When especially when the error is too small, we need some precise over that maximum tracking of MPP. We need some highly technical skills to develop the control structure. And the algorithm like sliding mode control, uh, yes, here we have a major problem is the chattering. So we are going for the new methodology like FLC PSO. What it is? Let's see the proposed methodology. Here from the panel we can get voltage and current, which is given to the maximum power point control algorithm, power point control algorithm, which operates the duty cycle of the DC to DC converter to the maximum power point with its control structure, with its controls principle, with its control design. How the design is and how we can track the maximum power efficiently. Let's see here why FLC PSO. The PSO is actually particle swarm or optimization algorithm is very effective in nonlinear problems, but still, what is a drawback in tracking the MPPs in the sense it is very effective in tracking the maximum power point in single peak, which means with constant irradiation for constant irradiation and temperature. The curve we have got as the PV curve we have got as have only one single peak, only one peak. It is very effective in tracking that single peak, but when we have dynamic variations, the PV curves possess wide nonlinear behavior. Experimentally, uh, what we can see in theoretically, we model mathematically, we can model in mathematical sense of a PV system, and we have got some PV curves. We know that we have, when we have dynamic variations, which means under partially shaded conditions, we may have multiple peaks. But in this PSO, what happens in the sense, for multiple peaks, it shows poor success rates in tracking the global MPP even in n-dimensional search space. What? Where it fails? What is the reason on tracking failure over global MPP? Just because of this inertia weight in PSO. What happens in the sense, in PSO we are choosing the inertia weight randomly. What happens, the small step sizes or high step sizes, which leads to the tracking failure, which means extremely less weight or heavy weight leads to the tracking failure. That's why with this sensation we are moving to improved particle swarm optimization. Here what change is made in the PSO? Here what we have done in the sense, we have given some adaptation weights in the PSO, which means we have given some fixed weights. That is, the linear variation in the inertia weight is given to the PSO algorithm. But still, it does not give the exact search space, as the PV curves possess wide nonlinear behavior for dynamic variations in the system under partially shaded conditions. That's why we are, so what we actually need, we need a dynamic inertia weight which can be provided by the fuzzy system. That's why the proposed methodology is looking on fuzzy system based inertia weight in PSO. From this we can extend the nonlinear search space to track the global MPP in the fastest convergence rate. That's right. That's the thing. Here, that's the thing. The fuzzy system is developed for the dynamic inertia weight in PSO, which ensures extended nonlinear search space, which can which can track the global MPPT almost to the exact with fastest convergence speed under partially shaded conditions. That's it. Uh, we can see from this FLC PSO, we can justify the significant role of inertia weight in the PSO algorithm. How it shows its significant role, how the inertia weight can show this significant role in PSO algorithm on searching of optimization point in n-dimensional search space, especially in nonlinear problems. That's with this sensation FLC based PSO methodology is proposed. Afterwards we can see how the control structure is designed in FLC PSO, and how it works, what is the control design principle, and how it works, and what we can justify with the results. Afterwards we can see to that. Thank you so much.